Okay, now we are going to be talking about multiplying matrices. This is one of the most interesting topics on matrices, and it can also be a little bit confusing. So strap in and let's get to work. So we're going to start off by understanding the rules for multiplying matrices. Like I said, this can be a bit confusing, so I'm going to make sure that I follow a lot of steps so that you can see exactly how to avoid some of the challenges that students typically have with multiplying matrices. And then after we look at the rules for multiplying matrices, we're going to talk about the steps that I will recommend and I'm urging you to follow whenever you're multiplying matrices. And once we're done with all of those, we're going to apply everything that we have covered, the rules for multiplying matrices and the steps for multiplying matrices. We're going to apply those to solve some examples together. So what are these rules that we need to follow to multiply matrices? The first one is that the number of columns, remember that whenever you are naming a matrix, it's always the number of rows by the number of columns. So what we're saying here is that the number of columns in the first matrix must be equal to the number of rows in the second matrix. So what we're saying here is row by column and then row by column. We're saying that these two numbers must be the same. If they are not the same, you cannot multiply the matrices together. And the resulting matrix, which is called the matrix product, must have the same number of rows as the first matrix and the same number of columns as the second matrix. So let me just simplify this. What we're saying here is if I had something like this, if I had a 2 by 3 matrix and a 3 by 3 matrix, because these values are the same, we can actually perform a multiplication, and our matrix, which is going to be called the matrix product, is going to be a 2 by 3 matrix. Now, if I had something like a 1 by 2 matrix and a 1 by 2 matrix, you can see here, these values are very different. So just for that reason alone, we cannot multiply these matrices together. So those are the most important things to remember. Let's go over it again. The number of columns in the first matrix must match the number of rows in the second matrix. And then the resulting matrix or the matrix product is going to have the same rows as the same number of rows as the first matrix and the same number of columns as the second matrix. So one thing I want you to see here also is that in multiplying matrices, it's not always true that A multiplied by B equal to B multiplied by A, because you have to obey the rules of the matrices that we have covered in this part of the lesson. Now let's talk about the steps that we need to follow to multiply matrices. Well, we need to first make sure that the matrix obeys the rules that we just covered, which means that the number of columns in the first matrix must match the number of rows in the second matrix. You have to do that first. The second thing is we're going to perform a dot product of the matrix using the rows of the first matrix and the columns of the second matrix. So you're going to do that for every row on the first matrix and the columns in the second matrix. So what you're going to see, for example, is we're looking at if I had a 2 by 2 matrix and a 2 by 1 matrix, for example, let's say we have A, B, C, D, and then we're multiplying this by, we have 2 rows and 1 column, so this is going to be E, F. So what we're saying here is we're going to multiply. Let me get a different color here so I can show you exactly what we're doing. So we're going to multiply this row here by this column. So what we're going to have is A multiplied by E, plus B multiplied by F. So that is you're going to see why the rules that we discussed earlier are important. And then for this also, we're going to have, this is only one column, so that's why we're doing it only once. So this is going to be CE plus DF. So you can see here that our matrix is actually going to look like this: AE plus BF, CE plus DF. Look at what we have right here. We have, remember, this is important, these are the same. So we have a 2 by 1 matrix, so we have 2 rows and just a single column. So this is why we need to pay attention to the rules that we discussed earlier. Let's actually go ahead and do some examples and see and put this into practice. So we have, what is the value of AB if A is 2, 3 and B is 5, negative 7? So let's start off by describing this matrix. This matrix is how many rows? We have 1 row and 2 columns. And here we have how many rows? We have 2 rows and 1 column. So this is going to give us a matrix that can be multiplied because the number of columns here and the number of rows here are the same, and we should be expecting a 1 by 1 matrix. So let's go ahead and do the multiplication. So we have 2, 3 multiplied by 5, negative 7. So we have just 1 row. We have 1 row here. We have 1 row here, and then we have 2 columns here. We have 1 row here and 1 column. So what we're going to have here is, let's put a multiplication here, is going to be 2 multiplied by 5 plus 3 multiplied by negative 7. This is going to be our matrix. So this is going to be 10 minus 21. So this is going to be the matrix negative 11. And you can see here that this is the 1 row, 1 column matrix as expected based on the rules that we discussed earlier. Let's go for another example. So we have AB, we have A here and we have B. Let's look at this. This is a 2 rows and 2 columns, so 2 by 2. And this is also a 2 by 2 matrix. And we can see that the number of columns here and the number of rows here are exactly the same. So we should expect a 2 by 2 matrix. So let's go ahead and write out the matrices. So we have 2, 3, negative 2, 5. And we're multiplying this by negative 4, negative 1. And then we have 3, 7. So we're going to perform our dot product. So we have row here and then column here. We're going to multiply this row here by this column first. So we're going to multiply this way first. So this is going to give us 2 multiplied by negative 4 plus 3 multiplied by 3. And then that's this column. We also need to go deal with this column here. So it's going to be 2 multiplied by negative 1 plus 3 multiplied by 7. So now we've done this row here against the columns on this other matrix. So let's go over and attempt to do the same for this row. So we have negative 2 multiplied by, so we have negative 2 multiplied by negative 4 plus 5 multiplied by 3. And then over here, we have negative 2 multiplied by negative 1. And then we have 5 plus 5 multiplied by 7. So this is going to give us the matrix that these are going to be our resulting matrix. So 2 multiplied by negative 4, we have negative 8 plus 9 over here. Then we have 8 plus 15. Over here we have negative 2 plus 21. And then here we have 2 plus 35. So this is going to give us negative 8 plus 9, we have 1. 8 plus 15, we have 23. Negative 2 plus 21, we have 19. 2 plus 35, we have 37. So you can see here that we end up with a 2 by 2 matrix as expected. 2 rows here, 2 columns here. So that's how you perform a multiplication of matrices. Let's go for the final example. What is the value of AB if A is this and B is this matrix? So let's start off by describing the matrices. We have how many rows? 2 rows by 3 columns, and here we have 3 rows by 2 columns. So we can actually perform this matrix, this multiplication, because the number of columns here matches the number of rows here. So let's go ahead and start working on our multiplication. I always have a habit of writing out what I'm doing. So it's going to be 1, 0, 3, negative 7, 4, negative 6. And then we're multiplying this by 2, 0, negative 1, 3, negative 4, negative 2. So we're going to start off by picking we're going to go row here and multiply by column. So let's go ahead and pick out our row, this row over here. We're going to multiply by this column right here. So this is going to give us 1 multiplied by 2. So 1 multiplied by 2 plus 0 multiplied by negative 1 plus 3 multiplied by negative 4. And then we're going to do that also for the second column. So we have 1 multiplied by 0 plus 0 multiplied by 3 plus 3 multiplied by negative 2. Now we go for the second row on the matrix on the left side. Negative 7 multiplied by 2 plus 4 multiplied by negative 1 plus negative 6 multiplied by negative 4. So now we go over to the second row, the second column on the matrix on the right. And so negative 7 multiplied by 0 plus 4 multiplied by 3 plus negative 6 multiplied by negative 2. And so let's go ahead and simplify. 1 multiplied by 2, that's going to give us 2 plus 0 minus 12. This is going to give us negative 14 minus 4 plus 24. And then on this column here on the right side, we have 0 plus 0 minus 6. And then we have 0 plus 12 plus 12. So this is going to give us 2 plus 0, 2 minus 12, this is negative 10. Negative 14 minus 4, negative 18 plus 24, this is 6. 0 plus 0 minus 6 over here. And then 0 plus 12, we have 24 over here. So you can see here that we have a matrix with 2 rows and 2 columns. And this is going to be our resulting matrix.